if you're going to make large volume products like bioplastics, like food proteins like egg whites or milk or just name it, large volume products, you will need many, many people coming into manufacturing. So while Fermbox and BioArc makes this technology, creates proof of concept, builds a couple of plants and shows it's viable, when it becomes really mainstream, we will need support from every industry that is available anywhere in the world to be able to do the biomanufacturing. So I see the reason that is exciting us is to go to all these potential collaborators and invite them to join the bio journey.
Hello and welcome to another episode of Speciale Focus, brought to you by Speciale Invest, a leading early-stage deep tech VC firm in India. And I'm Hari Arakali, your host. In this episode, I bring you a conversation with Subramani Ramachandrappa and Preeti Dharmagoudar, co-founders of Fermbox. They discuss their approach to building a business that sits at the intersection of biotechnology and manufacturing. Subbu, as those who know him call him, recounts lessons from his entrepreneurial journey, including founding Richcore Life Sciences and seeing it acquired successfully, before the decision to launch a new venture focused on precision fermentation-based production. Preeti outlines how her experience in strategic roles at Biocon and Abbott Nutrition is shaping Fermbox's product strategy. The conversation explores the company's ambition to apply precision fermentation to create alternatives to plant, animal, and petrochemical-derived inputs. The founders explain why they view India as a promising location for both research and manufacturing, drawing on local scientific talent and the national manufacturing base. In this conversation, the two entrepreneurs also offer their insights into technology development, including the practicalities of scale, commercialization, and collaboration. They also discuss Fermbox's asset-light and partnership-driven approach, the rationale behind its multimodal manufacturing model, and the outlook for scaling deep tech ventures in India's evolving bioeconomy. So, Subbu, Preeti, thank you for making time for this and welcome to the Speciale Focus podcast. I know both of you are, as they say in the startup world, serial entrepreneurs and operators and all that, and you've been in this ecosystem long before the phrase deep tech became fashionable in India. Again, for a general audience, perhaps it makes sense if you can take a couple of minutes just to give us a snapshot of your journey leading up to Firmbox and how you started this company, what gave you this idea. We'll go from there.
Thanks for having me on the show. Yes, so prior to Fermbox, I was a very long time biotech entrepreneur in a company called Richcore Life Sciences. Richcore Life Sciences was a company I started in sometime around 2000 after spending about a year in Biocon. That's where I met Preeti as well. And I was in Biocon briefly for a year to help them sell enzymes for textiles. And then I started my entrepreneurial journey mostly because I needed to make more money for my family. So, no surprises there. So, having started Rich Core, I wanted to conserve food, energy, and water. And I think it was the time when Al Gore's inconvenient truth was very vogue. I wanted to conserve food, energy, and water using biotech tools. And that journey was very interesting because we built some really fantastic products to clean up wastewater, to make sulfur free sugar. Now we want brown sugar, but then we wanted wine. So basically, we were a little early to market. So there were a lot of learnings there. And then in between, I joined ISB. I did my MBA because I felt I was a little too local in my thinking and I wanted to look beyond. And ISB really helped me see how the world of business works, how entrepreneurship is built with more partners, with advisors, with investors. And then I managed to raise some funds in Richcore, first from Venturies, then Fidelity, which is now Eight Roads. And we moved from being just an enzyme company to making recombinant proteins or animal-free products for biopharma industry. So we made products which are used in insulin, in vaccines, in cell culture. In fact, we feature in Kiran Mazumdar's book as one of the companies which grew out of Biocon in a way and also produced a product which helped them access US and European markets. And then in 2016 and 17, the world changed. We were making animal free proteins for biopharma, but then people in the world, especially in the more riskier investor environments like in Boston, MIT, Israel, Japan, people wanted to produce eggs without chicken or, milk without cows, because the same biotech tools which we could make animal free proteins, you could make colors, dyes, flavors, milk, eggs, even meat, for instance. And these guys were in the lab and they wanted to scale up. And somehow at Richcore, we had this ability to not just produce the tech, but also manufacture this in large scale. So they started reaching out to us, asking us to help them scale. So many of the products launched in US, Europe happened through Richcore. And then we became very attractive to many companies, both investors and strategics. And Loris Labs, which is is a pharmaceutical company in Hyderabad, wanted to latch on to the bio contract manufacturing space because they were in the chemistry manufacturing space. And they gave an exit to my existing investors, which was Venture East and Eight Roads. And then I continued to be there with a goal to create what I would say a global fermentation company. And then I spent a couple of years, and then I realized that in order to build the vision that I had to be free of any legacy businesses or contracts. So I created Fermbox as a means to co-develop, co-create, and co-commercialize biotech for the world. And when I wanted to do this, I also realized many of my industry colleagues, many other technical people whom I knew wanted somebody to build this story. And it just came together at Fermbox. So Fermbox is fermentation and sandbox, and we intend to ferment the future. So that's how Fermbox happened after my long journey with Richcore.
Okay, very nice. I was speculating in my head if, or rather, I was wondering if Fermbox is about fermentation in a box, but more interesting way in which you came about the name fermentation and sandbox. Uh, Before I ask the next question, Preeti, if you want to add anything to this, I'll wait for you first.
Thank you, Hari. We both, me and Subbu, have had a slightly different path leading up to this point. When Subbu started Firmbox, it was quite inspiring to see him, restart his entrepreneurial journey and not take it easy after his previous exit. So when the opportunity to contribute to Firmbox journey came up, I was really excited because the role meant that I could contribute in a way which dipped into my previous experience. Subbu, of course, has been a biotech entrepreneur from early on. But I myself have had more of a corporate journey, you can say. I joined Biocon at the start of my career, at a time when not many outside Bangalore or Karnataka may have heard of the company. The company was reasonably small at the time and very entrepreneurial in nature. As a business, the company was moving from industrial enzymes to hardcore pharmaceutical APIs. API means active pharmaceutical ingredients. So that's very common in the pharma field, very different from probably API in the tech IT field. And as youngsters, we were given, big responsibilities. And I think that learning through more than a decade was invaluable. I was leading strategic outsourcing and product and business strategy for the API business at the time. And subsequently, I did a couple of international consulting stints, worked with Abbott Nutrition in their global innovation office, And in between, also did a year at ISB, also refreshing, my outlook on business, learning aspects to business that I may not have been exposed to in my daily work. So, getting to the Fermbox journey has been very different for both Subbu and me. So, yeah. So at Fermbox, just to give you a little snapshot, I lead product strategy, which means looking at the R&D pipeline with a commercial lens and helping put product market fit front and center.
Hari, I must add here. So, Firmbox is not just two of us as co-founders. We have another core co-founder who's a technology head who's just come on board, Mr. Ramanan. Apart from him, many of my other colleagues whom I worked with in the past, either as customers or as team members, they're all kind of co-founders. They're all invested in the company, and now this journey has been really fun because we have a really top heavy capable team at Firmbox because it's deep tech. It's not something you can be frivolous about, and biotechnology requires many different disciplines. So I would say Firmbox is truly an entrepreneurial team rather than just two co-founders.
Okay. Can you now both dive into giving us a sort of layperson's understanding, but nevertheless a rigorous understanding of what's at the heart of Firmbox? What's the technology you're developing? Maybe what is currently the core product pipeline or flagship products, as you all call it, and we'll go from there.
Thanks, Hari. So for a moment, let's forget that we are a bio company. Okay, I would actually describe ourselves as a new source for materials we currently depend on, plants, animals, or chemistry. So basically, we make alternates to the materials we already use, but we're producing them using fermentation. So it could be a color or a dye or a flavor or a fragrance or an enzyme. These are usually stuff we harvest from forest, from animal parts, bodies, their skins, or using harsh chemistry which is coming from fossil fuels. We believe that the future these resources will not be as abundantly and easily available as they are now, and we would want to produce more with less. For example, if you wanted, say, whey protein, why grow hooves and the horns of a cow? You can actually have a small footprint like a brewing center where you make beer, but you have designed the genomes of a bacteria or a fungus or a yeast to be able to produce a product or an enzyme that you need, which you otherwise depend on natural or chemical sources. That's what we do in Firmbox. And I'm very proud to say that we've been able to build and launch two products, one being an enzyme to harvest sugars from biomass as an alternate sugar source. It's primarily being used to produce 2G ethanol, but the same sugars can be used to make other products, including food and proteins. And the second is a fragrance which smells like freshly cut grass, which otherwise came from chemistry or mint, like pudina in India. And now you don't have to depend on crops with pesticide or chemicals from below the earth. You could actually produce them using simple sugars in a fermenter. And then the next product is macrocyclic lactones, which are also a fragrance like of musk. These are used in the flavor and food industry. So we have a series of products planned to be produced in fermenters like we make beer, like we have many different types of beverages, we could brew many different types of products. To do this, we need two core capabilities. One, the strain engineering and enzyme engineering, as we call it. These are slightly technical terms, but one should be able to um, design a system to put a particular gene or a particular sequence into a genome of a living cell like a bacteria, yeast, fungus, whatever, and be able to grow them like, in the past, insulin came from animals. Now it comes from yeast, from bacteria. produced by companies like Biocon in fermenters. Similarly, you could actually take the gene or a sequence which is responsible for a protein or an enzyme and fuse that, like you do copy paste in software, into the genome of a living cell, and then use that living cell as a factory to produce these products. So at Fermbox, we do both strain and enzyme engineering. We work on microbes. Most microbes are, single cell. They live on their own kind of stuff for the layman, but otherwise they are bacteria, yeast, fungus, and stuff like that. And that's what forms into what we call the BioArc platform. We call it the Ark, like the Noah's Ark. So we're trying to build a new boat with all kinds of expression systems so that the world in the future doesn't have to forget the products we got from nature, but can now make them even in space, in very small spaces, even in your own kitchens, without having to go out and hunt something or harvest something.
If you look at companies in the biotech landscape, most companies specialize very narrowly, either in a single technology platform or a specific product vertical. I would say that our strength is fundamentally different. We operate across multiple host microorganisms and we integrate the full spectrum of modern biotech tools from molecular engineering to fermentation design and downstream processing. So, this cross platform capability makes us industry agnostic as well as product agnostic. So, it enables us to deliver solutions driven purely by technical feasibility, commercial viability, and speed to market. If you can say, one of our core strategies is to evaluate every product or process development approach in R&D through the lens of scalability. So lab environments, as you would know, are controlled, predictable, and resource dense also. But large scale manufacturing is not. So the shift from bench to pilot to commercial scale introduces very different, constraints. And these realities cannot be appreciated just from theory. You need experience to, know what will work or what won't work. And I would say that our team brings that deep scale up expertise that allows us to identify early on whether a given technology or a process can be scaled viably and what specific challenges must be anticipated and engineered for, a manufacturing environment.
Yeah, that's a good point. I think, Preeti, you brought. So I want to highlight here that a bio company has to make a physical product. So it's not like you upload something on the cloud and you can have it in your app, right? You basically have to physically produce it. So our our business requires us to not just do this molecular biology, use artificial intelligence, machine learning to develop these clones, but we should also do the engineering. So, in a way, there's a convergence of biotech and real physical engineering, which has to come together to make these future products viable. And I think that is the crux of what I would say really deep tech, because there's one end you're going really deep on the biospace that is below the microscope kind of area, and then you are going into energy efficiency, water efficiency, continuous versus batch process, purification, removal of waste, dealing with wastewater. So it's really multiple deep techs coming together. And I think that's what's really exciting for us, because we are both a bio and an engineering company, and bringing them together is what makes the journey very exciting.
Okay. I also want to give our listeners a quick sort of idea of why you talk about precision fermentation. Can you give us a sense of what you mean by that?
Sure. So, like I mentioned, if you want to produce a product, let's say you want to make a fragrance, and you figured out this is the sequence in the gene which is required to be plugged into an organism, and you did that successfully in the lab. Now, that particular cell or a microbe, the living cell, is your production host, or that is your factory, right? It's your biofactory. Now, if I want to produce the product from that one cell, I can only do a certain quantity. If I want a lot of that product, the fragrance, I have to grow many of these cells, right? Like something like making yogurt. You take a few cells, you grow them, put them in a 1 liter vessel, then put it in a 100 liter, then put it in a 100,000 liter vessel, and you keep scaling up. So if you want to produce just that one fragrance in your batch, you don't want other organisms to get into the same vessel. Like curd, making yogurt is an uncontrolled, non precision fermentation, in my opinion, that's what it is. Similarly, making beer is an anaerobic process. So the fermenters are quite open. It's okay if other organisms get in because that's how it works. But if you want to produce a particular fragrance or flavor, you want to be precisely growing just one organism. So the entire process is sterile. So, from when you inoculate the organism to what you feed, the air, the water, the purification, eventually until you separate the final product in your final process, the whole process is sterile. Now, if you want sterility at like 1 lakh, 2 lakh, 5 lakh liter fermenters capacity, I mean, that many liters of fermentation volume, you better be precise in what you put into these tanks. So that's why the word precision, because you will not succeed unless you have precision. And this precision is needed sometimes over 2 days, over 5 days, over 10 days, because a batch could run for 12 days as well in a fermenter. So all the way from start till the final product, you want to ensure sterility. So you're basically making biomaterials like you make monoclonal antibodies or vaccines as sterile as they do. So that's why it's called precision fermentation.
And in this context, is the know-how of how to do this, how to achieve the type of purity that you want to make sure that there's no contamination, etc. Is that now know-how part of what is proprietary to Fermbox and the technologies that you're developing?
No, I'll tell you what all is proprietary with what we do. One, how we engineer the organism is proprietary. That is no brainer, right? You would understand that because you're dealing with genetic modification. So you could be very innovative and have very new ways in which you do it. And then you go into scale up. When you scale up from, say, a small petri dish to even a few 100 liters of fermentation volume, you have a lot of learning in how you feed the raw material, what kind of carbon, nitrogen, oxygen sources you need, how do you manage your heat, is it a continuous or a fed batch process? These are a combination of intellectual property and know-how. And the know-how is driven a lot by past experience of scaling up many processes. And when it goes to large scale, so I'm giving you the example. One is in the lab. Second is in the bioprocess lab where you do fermentation. Then comes the large scale. Now, in large scale, there's a lot of knowledge, IP you can generate, and how efficiently you can run this process because you want stuff like food proteins to be ultra cheap. You want to reuse many of the materials in the media or spent media that you have. That is an area of IP. You want to see if you can collect the cell mass at the end of fermentation and reuse that as a nitrogen source. So, so a lot of these processes are kind of intertwined with IP and know-how. So when we file IP for the organism or the way we have constructed it. We also file IP in what kind of processes we used in order to produce this product viably. Because anyone can produce a product at any cost. The question is, how could you do it so efficiently and viably? So these are the areas of our IP.
And BioArc, if I understood it correctly, and correct me if I'm wrong, is the underlying platform that you are going to use to produce different products with sort of the underlying know-how is the same that is encapsulated in BioArc. Is that correct?
Yes. So let me explain BioArc a little more in detail. Just imagine BioArc is like a layered cake. Okay. So the first layer is strain and enzyme engineering competence. So that is the bedrock on which you start building products. So that's like learning two software programs, I would say. Okay. Above that, we use a lot of tools: molecular biology, genetic engineering, we use computational biology, etc. So these are horizontals that are there in the next layer, which allows us to further enhance what I would say is the core enzyme engineering and the protein engineering, strain engineering competence. Once we surpass the next layer, the layer above that is about process development. The process development is which I just mentioned to you in how do you take an organism which is like few cells in a dish to say 100, 200 liters. That's where a lot of work gets done. So that forms, and that is quite common to most of the products, right? That's where the product comes into what I would say common science. And then the following layer above that is purification. How do you separate an E. coli to a pichia, which is a yeast, to a fungus, which is a filamentous fungus? And then how do you purify the product of your interest is the next layer. Now, all these layers become part of what I would say a bioarc. It's almost like an automobile assembly system. So you go from strain and enzyme engineering, you go into molecular biology, followed by process engineering, followed by purification and cell separation, and then the final product. All this happens before it goes into manufacturing. Since many of these horizontal layers are common across products, we can produce many different products which sell to many different segments. But more than 60% of the science we use is a platform. And since it makes many products across segments, we call it an arc where the platform can deliver without having to pivot. The products can change at Fermbox, but the science will remain and will be able to churn out more and more options.
The arc also links to, lab to launch. So the ability to go fast in terms of development as well as commercialization.
See, one of the things I can add here is that most startups are biofoundries. They are in the lab. Very few of them have the competence to be able to design, build, and operate large plants. So the learning that they have to be successfully be able to make viable large scale products is a missing piece. So a biofoundry cannot survive on its own. A biomanufacturing company cannot survive on its own unless there is a biofoundry which feeds it with products. So that's why Firmbox has a multiplicative benefit or a competing edge compared to a typical contract manufacturer and compared to a typical biofoundry. So we are both a biofoundry and a biomanufacturing company together.
So basically, these are two very different skill sets. One is you have to imagine scientists in white lab coats working in the lab, right? And they're developing the technology and they are able to scale it up. And then these are physical products which need to get made in large scale manufacturing. So there's that competency which you need, which is to, like Subbu said, to design, build, and operate large scale. In our case, it's precision fermentation plants, right? And then the third aspect is commercialization. So how do you get it to market? So these are like very different skill sets, and the ability to get it from lab to launch and do it, in a seamless manner is also part of the bioarc kind of output, so to speak.
And also, Hari, in order for us to be successful, we tap into many other deep tech areas. For example, I know your previous conversation was with a very renowned uh, genetics expert, right? Vijay Chandru and CRISPR bits. So we would need to use technology like CRISPR to do gene editing. We would need to use stuff like what another company of special like Peptris does, which is using AI to make prompts on what other proteins we could design. We would have to use precision control valves, for example, which comes through air valves or media pumping equipment, etc., which comes from a whole manufacturing space. We work very closely with online controls of our process system. So it's if you look at any business case in a business school, you will see you'll always have a few cases around biopharma or manufacturing, because this is one area which actually uses physics, chemistry, biology, mathematics, computation, all to make one product. And think that's why this becomes both deep and broad. So the area of syn biology is both broad in terms of tech and deep. So it's a really big moat when you actually produce a product and go to market. And that's why there are so few companies even in India, because this research is risky and it's expensive. So unless you are able to translate an idea into a commercial product, there'll be very few investor interests as well. So you will see companies like Lotus Labs buying Richcore, because it's not easy to just assemble 50 people and say we're going to get into biotech. You will see even a Dr. Reddy's or their family office investing in a company like Zenfold, because the know-how of how to build these technologies comes not just from theory, as Preeti said, but with a lot of experience that people in the team bring to the table to make it work. It's literally like doing an opera.
I call it a series of waltzes.
Very nice. And in your layer cake analogy, would you say that you call BioArc a full stack platform because you are controlling every layer to your own specifications and so on, and you own the tech?
So we own almost all the tech we build, but we may build the tech in collaboration with some people, because you can't be an expert in everything. For example, just think of a chassis made by an Ashok Leyland, right? So there's a truck chassis on which you can build a bus or a truck or a caravan or even a vanity van, right? But in biotech too, I may access the host organism from one of the guys who have an empty chassis, and then we build on it. To that extent, we collaborate, because that's the norm in the industry, because people have worked on expression systems like a chassis of a bus or a truck, and then we build all our techs on it. So to an extent, we do collaborate a lot on this part of our development. And the rest of it, we like to work with collaborative manufacturing, where we actually encourage companies who have utilities, resources, sugar, like Indian sugar mills, distillers, to actually just give us some space. Because many times when I've built a plant before, I've seen that 60% of my time is in managing utilities, and more than 50% go of my capex is for utilities. So if I co-locate with facilities where there are utilities that I need, like power, water, steam, wastewater treatment, land, then my capex comes down and my opex comes down. So the layer cake feeds into these collaborative models that we have for asset light manufacturing and commercialization. And commercialization, we don't try to sell the ingredient we make to the end user. For instance, if we made a fragrance, we go to the guy who's currently buying these fragrances from plants or from chemistry, so that we don't add a competition, but we actually work with the biggest player, and that he has an existing distribution system. So we make sure we have enough margin so that you can provide that to your reseller, who is the biggest, most dominant ingredient player in that space. Because when you're product agnostic, you cannot become an expert in all industries. For example, if I made a product for a pulp and paper industry, I wouldn't know exactly how that industry works. So I may as well work with somebody who works with the pulp and paper industry with many other inputs, and he becomes the best suited guy to provide technical support for the end user to use. Similarly with a food color. So we made a food color, and how would I know how to color the food? But what I do know is my food color is exactly same as the food color he got from chemistry or from an insect. And technically, I can prove it's the same, but in applications, we lean on the industry partners to take it forward. So for us, BioArc is the engine from where we produce our products, and then we collaborate with the required partners with more experience than us to get that job done. That's why we say we co-create, we co-locate, and we co-commercialize.
Okay. Um, you started the company formally about 3 years ago, I would say. And can you give us a sense of on your commercialization journey? Where are you at today?
So it's interesting. We did register the company in December 2022. So effectively, we are like about 2 years in business. Two and yeah, 3 years. Sorry. And in this period, we have been able to develop three products, and we have successfully supplied and continue to supply our customers who are ethanol producers with an enzyme which they use in very large scale. We were able to produce more than 250 tons of this product and supply successfully with a good gross margin above 40%. Apart from that, we have launched one fragrance, which, as I said, smells like freshly cut grass, and another is a lactone, which is very similar to musk. So these are three products that we have commercially successfully launched, and one product is in repeat orders and revenues with very large public sector units in India.
So, can you talk a bit more about your approach to manufacturing? I mean, I know that there's been some news about already some partnerships and international ones as well. But I'm also interested in if perhaps the way you are approaching the business model is novel or more innovative in some ways. And if they are, can you walk us through your sort of philosophy behind this?
So, in terms of biomanufacturing, we have a very multimodal strategy. We, of course, work with CMOs. We work with partners with whom we do a deeper, commercial arrangement. We have kind of explored the co-located models, and we are looking to set up our own facility too. So we think that with a mix of these multimodal strategies, we are able to be a little asset light. We are able to uh, go to market faster, and we are able to be a little more nimble and kind of create strategies product to product based on what the product needs, because since our portfolio is quite different, each product needs its own different manufacturing ability, so to speak. So we think that with our multimodal manufacturing strategy, we are able to be more nimble and faster to market.
So I can add the four modes we have. One is over the fence. So there's a large customer, he needs a lot of the product. So we would love to build a plant just over the fence so that you avoid shipping, transportation, etc., etc. And he becomes kind of your sticky customer, as well as you use some of their resources to be able to deliver the product. The second is to be on site, where you build the plant on site and the customer actually provides you with the utilities, etc., and you're able to deliver the product at a far more efficient, cost efficient manner while retaining our margins and reducing costs for them. The third is, of course, the CMO. It's the easiest model whenever there's a product where there is a right contract manufacturer, CMO being organization. We actually latch into them and produce products, especially for prototyping, for scale up, for demonstration of cost. But some of the plants may be sufficient for us to even commercially supply. So we have at least three contract manufacturers signed up in India, some very large ones. So we fully operate those plants for our use. And third is building our own plants. So we've kind of working with the government of India. We have applied for the Bio E3 support. So with their support, we'll be able to also build our own fermentation facilities. And we've been recently provided a letter of comfort for 30 acres of land in Northeast in Assam, because we don't think that biomanufacturing is meant to be in Bangalore and Hyderabad alone. In fact, my previous company, we built plants in Tumkur and Mysore, and now we think India is ready to have these biomanufacturing plants in remote areas, and we are looking at building a facility as far as in Assam as well.
Okay. And in trying to do some homework ahead of this conversation, I also stumbled upon Bioprocess 4.0, in some ways applying what folks call Industry 4.0 ideas to this. Can you explain this to us in simple terms?
Yeah, sure. So bioprocess 4.0 is something like, how do you use data and how do you use automation? How do you use AI, ML uh, into your biomanufacturing setup? I think that it's not going to be, one big single monolith package that you buy and you're able to plug it in into your system. It's something that you'll have to do step by step. Success, I think, would be achieved by combining practical instrumentation, some good resilient design, some good sensors which are maybe retrainable, and then, of course, multi scale models which are continuously corrected by real data. So it's a lot about data and how we access data and how we interpret data in the lab, in the plant, in various workflows. So, yeah, this is something I think which will happen step by step for this industry and may not be something which will uh, be like one big, you know, ERP package that you can just plug in kind of.
Yeah. Sorry, I must raise a word of caution to blindly apply the 4.0 principles or the AI ML principles to fermentation. Like I said, the biofoundry and biomanufacturing are already very deep tech areas. And now we are trying to marry the biofoundry with biomanufacturing. You'll be surprised that even after first insulin was made in 1985, and now we are in 2025. Companies like Biocon, Eli Lilly, many others do fermentation to make products for human health to save lives. Most of them are still batch processes. None of them have become continuous processes. In fact, if you look at CAR T cells, right, everyone's talking about CAR T cells and gene therapy, personalized medicine, they're all run in batches. And when you're running in batches, there's so many variables from one batch to the other batch that first the engineering has to evolve. Right now, the bioscience where we are using AI, ML, CRISPR, etc., is taking off at lightning speed. So there is a great leap happening in the lab. The same thing is not translating in large scale manufacturing. So any 4.0 that you mentioned, if it's happening in the lab area, I think that's an area which will really increase the pace of invention to make new materials, which would be like plastic or whatever. But to take that and put it onto biomanufacturing, where you have different organisms, different products, different processes, different controls, you'll need to run a plant long enough to bring these kind of machine learning tools and automation to it. So there is a lot of effort being put by the automation companies whom we work with to kind of slowly build that knowledge, but it's going to be a while before engineering can truly leverage from the modern day um, intuitive machines, if I can call them. It's going to be a little bit of time.
Mm. When it comes to the deep tech aspects of your work, in terms of R&D and product development and so on, can you both talk about what's been the experience so far in terms of doing this out of Bangalore and India in general? Any advantages that you can talk about, as well as any challenges that you've encountered?
Um, I think in the lab, the building tech part of it, Bangalore especially is well suited. There are industries around from which there is talent available. So especially India, we have the biopharma space which is quite well developed. So you have already all the talent pool available, and it's just a little bit of extrapolation to move from biopharma to all these related other industries which are still biotech oriented, right? So India has actually a good, mm, uh, I can say, a lead and advantage from a talent pool perspective. Um, and I think the building tech bit, we are getting there slowly. So I think that is going to be an edge that India will have. Of course, biomanufacturing also, talent exists, infrastructure exists, of course, needs to expand. Um, and From a cost perspective, from a experience perspective, again, India has a lead in the space.
Yeah. So, Hari, there is an interesting problem in India. If you're looking at doing innovation, right? You're looking at PhDs who came back to India, or the excellent talent we have in companies around Bangalore, Hyderabad, Pune, Mumbai, the PhDs from IITs or the best science institutes, IISc included. Now, these, what I would call white coat team members, would want to be in cities. So it's almost impossible to take innovation to a very remote place or even to a tier 2 city like Hubli and be successful, because their natural draw is to come back to the city where maybe both the spouses are working or the kids have better school or there are more options, like with more companies nearby. So I would say for a reasonable time, the innovation would stay in these city centers like Hyderabad, Bangalore, Delhi, now maybe some parts of Kerala as well, Maharashtra. But it may not go to centers like Assam, Orissa. But biotech has two clear parts. One is the white coats, the innovation area, and then the manufacturing. The manufacturing is truly blue collar in biotech. It's just getting a light blue color when it's done for biopharma and for humans. But when you look at making materials, like where are all the distilleries, fermentation, they're not in cities because you need a lot of water. You can't build them around cities anyway. So the natural tendency for the engineering and large scale manufacturing will be tier 2, tier 3 cities. Now, are there talent there? No, you may not get necessarily biotech experienced talent, but the way we look at it is to repurpose talent. If they work, say, in a hospital, they're doing microbiology of pathogens, they can actually do microbiology in a manufacturing plant where we make these novel proteins or novel food, or a new kind of color or flavor. Similarly, if somebody's working in the fermentation areas, like in distilleries or even in a large scale food plant, food processing plant, we can actually groom them to operate these otherwise complex looking, but with training, an average IQ Indian will be able to operate this. So, what we are doing in these locations is to repurpose experienced people from other industries to whom, or I would say sister industries, to come and jump into our manufacturing. The rest is utilities, as I said. 65% of the facility is power plant, generators, wastewater stream. So, I don't see any dearth. And also, these blue collar team members would love to be closer to home. They are the people who work 6 days a week, 9 hours a day, or 8 hours a day, work in night shifts. So I see a great advantage doing large scale manufacturing in tier 2, tier 3 than trying to do it in city centers. So it's a natural fit for us. For India, we can leverage the high quality talent pool for innovation in cities and also leverage homegrown engineering talent, operational talent, production talent that our tier 2, tier 3 have historically provided to automobile industries, to computer industry, even mobile industry, right? In fact, Assam is also building the largest semiconductor facility, I think, of Tata or somebody. So I think the tier 2 cities will be the manufacturing power of India, even in biotech.
Okay. I want to bring you back to the big picture comment you made at the outset when we started our conversation. You described yourself as someone who's trying to develop a new source for materials that we need, that we are already using. Um, and I want to add to that, the point that I think scientists and including yourselves, technologists, I think you all agree that for us to make the planet, or rather our existence on the planet, more sustainable, the proportion of biomaterials in anything that we use needs to be much higher than what it is today. I don't immediately remember the source, but I seem to recall that proportion needs to be some 30-40% or something like that. And correct me if I'm wrong, and if you know, if you come across this. And currently, of course, that proportion is very, very low. I wanted to make this observation to ask you the following question: in the longer term, in the future, how do you see the role that companies like Fermbox can play, in this context, connecting it to the challenges we are facing with climate change today? Is there a role there that you can play?
Right. It's a great question, Hari. I believe, and we believe at Firmbox very strongly, that the need for these future resilient products, right, the day to day products we use, they have to become future resilient. The need for them coming from fermentation or bio route will happen over a cliff, like all of a sudden, like climate change, geopolitical risks, wars, famine, lack of water, pollution, degradation of soil. You cannot reverse them. Already, India is in the red zone as far as soil degradation is concerned. So, you will not be able to grow the same crop without putting more urea, DAP. This is already the case in India. So, naturally, the time at which the natural sources from plants or animals or chemistry will become more expensive than the biosource is not too far, but it will happen suddenly. And when that happens, you need many, many manufacturing capabilities. Like, just imagine there's this company we work with in Israel. They have made whey protein and they've launched it last week. And we are helping them, if possible, to scale up in India and other countries. If they succeed, how much milk or milk proteins do they need to make to meet or compete with every cow in India? Right? So it will need a manufacturing facility in every district, every county, every state. So no one country or state will be able to actually produce all that is needed for the world of these kind of day-to-day materials. Like fragrance, like I said, it's used in your toothpaste. The product we made one day may be in your toothpaste without having to depend on mint or chemistry. But if you're going to make large volume products like bioplastics, like food proteins like egg whites or milk or just name it, large volume products, you will need many, many people coming into manufacturing. So while Firmbox and BioArc makes this technology, creates proof of concept, builds a couple of plants and shows it's viable, when it becomes really mainstream, we will need support from every industry that is available anywhere in the world to be able to do the biomanufacturing, because you're competing or you're trying to replace agri source, you're trying to replace a forest source, you're trying to, like, for example, pine oil is no more available. So if you produce terpenes which can make few 4 or 5 thousand products that we use on in a daily basis in many of the chemicals and products we use, then you're going to have to replace vast hectares of forest produce with fermentation plants. So the way I see the role of ours would be to build this traction for shifting from these resource heavy materials to a more efficient process. And then these technologies will sooner or later get partnered or collaborated with other manufacturing houses or manufacturing entrepreneurs who can build facilities to actually produce the product. So I see the reason that is exciting us is to go to all these potential collaborators and invite them to join the bio journey, to invite, because there's a big moat. They think biomanufacturing we can't do it. So we are taking the deep tech of bio to the distillers, to the sugar mills, to the paper mills, and saying, hey, all you need to do is this. We will take care of this small piece. That's how we want to ferment the future.
I agree with Subbu when he says that things will change suddenly and drastically, or there'll be a cliff which will cause industries to transition, so to speak. Um, I think you can kind of bucket it into two aspects. One is the climate aspect, where We are seeing so much change in how crops are getting affected, how weather patterns are changing, and what the outcomes are. And the other, with the world in its very, very turbulent times that we are seeing, and how geopolitical risks are just every day is a new story, and you don't know what news the next day brings. So I think national security is impacted by both these factors. And biomanufacturing across industries, right from biopharma to leading to all the other industries that we touch upon. Uh, Biomanufacturing is really, it's going to be one of those must have key focus areas for countries. And we're seeing that in China, we're seeing that in the US, where governments are putting extreme focus. We're of course also seeing it in India, to say that this is a sector of focus and we need to have more capability as well as capacity to do biomanufacturing. So yeah, we think that there will be more push, not just based on a good to have, but a real need uh, in the coming future.
Okay. As we wrap up, let me bring you both back to more near-term future of Firmbox. Over the say next 12 to 18 months, can you both talk about what might be your top priorities, both in terms of tech and product development and in terms of expanding your business?
I think for me, what would look, as our company grows, what would look like success to us would be, having a real healthy portfolio of products which drive revenue, of course, but also drive impact on whatever sectors we are operating in. So, but yeah, I think that's what success would look like in the next few years.
So, in a real measurable terms, if you want to know, we are operating in a very complex environment where investors haven't really experienced many stories in synthetic biology or in deep tech that is in our areas. There's a lot of other deep tech. Only now the space and defense is attracting traction, but there are so few stories around successful synbio teams that we are facing a real uphill task when it comes to investor environment in India. It's very different in US, Europe, Israel, etc., but not in India because somehow most of our investors feel this is not a viable business or this will take too long because they may have burned their fingers in making biologics or making first of its kind novel drugs, etc. I think SynBio is a real business. We are already operating at 40-50% gross margin using a CMO. So there are products in our portfolio which have 90% gross margin. This will be far better than any of the other marketplace technologies available and will drive real growth. So I would say our story now is to impact investor thinking about SynBio and make them more willing to invest. So our story is about viable real world products, technology, manufacturing, margins. Right now, we have launched 3 products. We expect to cross more than $10 million in the next 1 year with a very healthy margin of upwards of 50%. And the proof of the pudding is doing that. And when we do that, I'm sure all the investors whom we have engaged or who have not considered to invest in this space will start looking at other entrepreneurs and look at creating what I would call a mass movement of investing in biomanufacturing. I think personally, if we succeed, the industry will succeed. And if the industry succeeds, we will be right on top of it. And that's how we're looking at 1 year at a time. So in 2 years, we've launched and commercialized 1 product. In the second year, that is 1 year from now, we will launch 2 more products and we'll cross a $10 million with a very healthy margin, and also will prove our asset light manufacturing, the margins we provide to CMO and other infrastructure companies. We may be able to create a new asset class like a mutual fund for biomanufacturing where we bring the know-how, knowledge, and investors are willing to build like they did for power plants. We also want to show the Indian government that we can make in India. So we did that with the first product. Now we're making this product for the fragrance industry. We've also given a proposal to do soil rejuvenation using biotech, because by rejuvenating our soil and bringing it back to life by using low biotech with high impact, we may be able to not just double farmers' income, but also reduce the need for urea DAP. So there are very large impact projects, and we will get a hearing only if we are successful as a story. So I would say our goal now is to create that revenues, to create that interest in investors and the government to look at biomanufacturing.
That's it for today. You can find the relevant links in the show notes. If you're an aspiring founder in India interested in biomanufacturing, do look Fermbox up, as well as Speciale Invest. I'll be back with another episode of Speciale Focus. Until then, it's goodbye from me, Hari Arakli. Thank you for joining us.